If you're a C# developer and you've ever needed to build a command line utility, then this is the video for you. Alright, so today, as stated, we're going to be talking about command line interfaces, and we're going to be building a command line interface for those of you who do C# development that have ever encountered a need to create a command line interface, whether it's one that just processes commands when it runs one time, or one that is going to take multiple commands and runs sort of like in a repeated loop. We're going to basically show how to do it, and we're going to be using a library, a NuGet library called think.parser.text that does text parsing. So let's just get started, because this is real easy to do. So go ahead and start. And we're just going to create a simple console application for the purposes of this. There we have it. We're going to use a .NET Core console application. I'm going to be using .NET 5 just because I guess I like it. But here we go. So let's call it a say hello command line. So let it get started, and here it is. Here's our basic command line. Let's go ahead and let's change this to .NET 5. Save that, and then let's go ahead and let's get rid of the hello world. So we have our basic template. We do a build. Make sure that there's no problems. Well, it would be helpful if we had a close parenthesis. Here we go. Build that. And then let's get started. So the first thing we're going to need to do is download the NuGet packet. And to do that, right-click, click on Manage NuGet Packages. That opens up this super sweet tool right inside of Visual Studio. We go over to the browse. That's going to browse everything. We type think.parser. I think that's already there. Enter, and there it is, think.parser.text version 1.0.2. By the time when you use this, there might be future versions, so it doesn't really matter. I would assume that everything stays the same, so you should be able to do it with whatever version that comes up. So we have that set up, and let's go ahead and let's add that namespace. So using think.parsers.text, and there we have it. That sets up our command line parser. We can build that right now. And what we're going to be doing is we're going to be building this command line, and we're not going to build a traditional command line that just runs once. We're going to build a command line that basically allows you to type multiple commands to do multiple things. It gives you both options, let's just say. But all you'd have to do is add some kind of if statement here, or add a statement, a flag that you process here, and based on the processing, you do one thing versus the other. Okay, so first thing we're going to do is we're going to do command line parser dot parse. Okay, and then in here we're going to pass in args. Okay. Okay. And then we're just going to check what the results are to see if it's something that we're interested in. So results args are, let's say, interactive. Okay, so say then we do one thing, else we do another thing, okay? So in here, I'm gonna say console.writeLine. And over here, and this is just to get us going so we fully understand how this works. And I'm going to build this. In order to run a command line interface type of console application that you've created, you typically will have to, well, we can run it normally by just running from the command line and it'll work. But when you're debugging it, the best way to do it is actually go into the properties, and over here where it says debug, you see over here where it says application arguments. So you just add it in there, and this would be what you would have been doing if you were using a command line. So in here, I'm going to say, just type hello world, just like that, nothing else. Actually, I'm going to type say hello, just like that. Okay, and hit the build. And then let's run this and see what happens. Okay, so as you can see, it goes in here. And if you look in here in the args, there's two arguments. There's say and there's hello. Those are the things that I pass into the code through there. And what you would have typed in, if I just typed say hello command line, I would type next to that say, and then after that hello. So let's run past that. So that's now been processed. And then this argzar, all it does is check to see if this value is in there. So obviously this value is not. So it's going to go in here, non-interactive. And there's a result. It just says non-interactive. And we can, of course, run this again. So go over here and change that. And I'm going to say hello interactive. Save that. And I run it again. And what you're going to notice is that it's still going to fail, right? So why is that failing? Well, it's failing because those aren't the only args, right? So the argzar method really looks at what all the arguments are associated with the input string that's been passed in. And in this case, those arguments are, if I can just open this up. In this case, those arguments are say, hello, and then interactive, okay? So over here, we would have to pass say, hello, and interactive for it to actually work. And we don't pass it as one string, we pass it actually as each argument that needs to be passed in, right? So say, hello, interactive. Those are the things that need to be there. And now when I run it, I should see that it goes in there and it's going to display the is interactive flow, right? So we're not really gonna, we get that, and everything that you can do with the interactive, with the command line flow where you just run the application and it does stuff, you can also do with the fully interactive flow. And so what we're gonna focus on in this video, now that we've sort of like shown that you can actually import the args, is the other side of it, which is basically a fully interactive application, a fully what's called a REPL, right? A read, evaluate, print loop, right? Which is what a REPL is. So basically the way this works is that you're gonna enter in some command, you type it in, it's gonna keep on running. It's not gonna die or close once you're done running. So how do we enable that? The first thing we're gonna need is we need some type of Boolean value that determines whether or not it runs or not. So we'll just call it run. That's gonna equal to true. And then we need a loop that it basically runs through. So while run, go in here. And then inside of here, we need a way to read values in, right? But before we do that, we need something to just indicate that, indicate to prompt the user to tell them to enter a value. So go console.write, and then here, we're just gonna enter some command. Okay, and then we're gonna put that there. And then right after that, we need to actually, this is just a prompt to tell the user. So we actually need to do the read part of it, right? So over here. So we're gonna read line. Okay. And now that we've read the line, basically we can just, in this case, I'm going to just write what's been read right back out to the user. This is called echoing the results. So there we go. And I could run this right now, but what you would notice is that if I ran this right now, matter of fact, let's run it. It's going to work. Everything works fine. But it basically runs forever, right? Right. If I typed in close or end or anything, doesn't matter what I type in. The only way you can really end this is by essentially closing the program. So let's go ahead and let's add something that basically we can use to do the interpretation part of it, right? So this would be the eval part of it, basically evaluating the command that's been entered. So to help do that, we're going to add a switch statement. Then we'll do command line. Okay. And now in here, I can have a case for end. Break there. And when end is seen, it basically just sets run to false. And then for every other case, I can just use default. And then I can just pass this into the default. Okay. So we run this. And once it gets going, it's basically the same as before. Everything works as before, with the only exception that if I type end, it basically ends the program and it's done. So we're in a good starting point for what we're really trying to do, which is to incorporate full-on command line interpretation. That's much simpler than this. As you might imagine, if I run this, if I wanted to do something like delete second file, right? Or test message 1, now test message 32, okay, read second item, right? And maybe read item, and maybe the item is 1. These are all different kinds of commands that you can pass into a program. And I'm sure you've all used programs and you've passed stuff like this in. Obviously reading all these variations to what you can do is not easy, right? So that's really where where this command line interpreter comes in that it simplifies the process for you so that you can just focus on the specific patterns that you're interested in and then work from there. So let's go ahead and let's test that out. And here, end. There we go. Okay, so we've ended. Now what we're going to do next is we are going to go in here and use the same class we used before, command line parser, and we're basically parse the command line that's been passed in. And just like before, this is going to return a result, right? So call it parse result equals there. And now in this case, what we're going to do is we're actually going to be evaluating that result, right? So as you saw here, whatever you type in, whatever has been typed in gets evaluated, and you're basically using a switch statement to determine what to do with it. We're going to follow the same pattern. So we're going to say parse result, that first. Okay, so that would be the first argument that's been passed in, right? And then we obviously just want the text. So we're just going to do that text. So that returns us the first thing that's been passed in. Okay. And if that is end, then we end. But what if it's something else? So what if it's a case say? Okay. Then we're going to be processing what's been said. So let's start with having something say that just has one argument, say hello, right? So the way we would do that is we'd use the when clause as part of the case statement. So say when parse results dot args are say and hello. Okay, and in this scenario, okay, so in this scenario, basically, when you type in say hello, it basically prints something. So again, you can imagine this being used in a more complicated application to do multiple kinds of interactions. But basically, when I run this now, if I say hello, it says hello there. If I say hi, it says you said hi, it just prompts it. If I type stuff, it just prompts. So for whatever else, it's just going to prompt. If I say hello, types it. And then of course, if I end, it just ends, right? So the interesting thing about this is that it doesn't really matter what order you put things in. Now it's difficult to see here, obviously, because we know that the first thing that we always look for, the way we've coded this, is the say, right? So because we're always looking for say, if I ran this and I ran it, let's say in the opposite direction, I said hello, say, right? It's gonna say, it's gonna fall out of this because it needs to first match the first part, which is the say part, right? But we can illustrate this by adding another argument here. So we'll add the world argument. Okay, so now when we add the world argument and we run this, we can say hello world, and of course that will work. But we can also say world hello, and that will also work, right? So the secondary arguments, really none of the arguments matter. It doesn't matter what order they come in. The issue is that when if I went world say hello or something like that, then the first argument, remember we're taking the first parameter of the result and we're evaluating, right? So if I put a breakpoint in here and I hit enter, right? The first argument here is now world, right? And as you can see, the text for world does not match any of the case statements. So it's obviously not going to work, right? So the next thing that we can do is we can actually work with optional parameters. So let's say we wanted to say, so we're saying say hello, right? So just get rid of that. Right. So this particular one always expects a say and always expects a hello. There's no other way around it, right? So let's add an optional argument to it. So in this case, we're still using the case say. So I'm going to copy that over here to start as a template. So we still are checking say first. But over here where it says hello, we can now use the or the pipe symbol, and then we can add as many optional arguments as we want. So hi, hola, and in Igbo, which is a Nigerian language, you can say kedu, which means the same, which means hello or how you doing. So these are ways that you can basically say hello. So let's run this now and let's see how that works. So say hello. Actually, before we run that, I just want to stop this and I want to show you the precedence aspect of this. So I'm going to just put a 2 here so we can distinguish between these two versions of say hello. All right, so now I say hello. Get rid of that guy right there. We run this. And as you can see, it's saying hello there. Why is that? Well, because this argument has been fulfilled. And because this argument has been fulfilled, it's not going to go on to the next one, right? Because it is, in fact, starts with a say, and the next argument is hello, that will work. But let's change it. Let's go say hi. Right. So now when you do say hi, as you can see, it's going into the second argument, right? Say hola goes into second argument. Say kedu goes into the second argument. They all work. Say goodbye goes down here to just echoing, right? So basically, when you use the optional argument, it will actually allow you to pass in multiple different parameters. So you can think of this as a way for you as a developer to constrain the kinds of values that can be passed into your command line argument, so that you basically know what's passed in. So let's take a look at what that means in terms of reading that value out, right? So we now know that you're saying something, right? Either hello, hi, hola, or kedu. In fact, I'm going to get rid of hello just because that's up there. So either hi, hola, or kedu. We know those are the possible parameters that you can pass in. But how do we read that, right? So reading it is a little bit, it's not complicated by any stretch of the imagination, but it's not, it's quite verbose. Let's put it that way. So to read it, basically, you just go parse results dot fetch, right? And what you want to do is, because we don't know what goes in here, right? We don't know what value has actually been passed. This is just a definition of what criteria needs to be met for it to satisfy this particular case. But we don't know which of these values the user has actually been passed in. So we can't search for these. So the easiest way to do this is to actually find say, and then basically, because we know that in this flow, the very next thing is going to be the value we're looking for. We can basically navigate to that from say, and then move from there, right? So we go say, so we're fetching say, and then we now go to the node, right? Because all these parameters are in something called a linked list. So basically, this is the node of the linked list that we're getting into. And then from that node, we now move to the next value. We could also move to the previous value. In this case, there will be no previous value. So if we tried that, it would fail. So we go to the next value. And now on that next value, we can actually retrieve the value. So we go down to value. And then from here, we can actually get the text of that value. Okay. So var Okay, so that is what was said. Okay, so we're gonna say, I'm gonna change that. What was said. Let's make this. Okay. So what have we done here? So basically, we've gone in and we've pulled this value out, and then we've basically parsed that out, and then we're returning that. So let's try it out now. I don't know any other ways to say hello, so um, pardon me, but I'm doing this all in real time. So we say hello, and that's gonna keep returning the hello there that's up there because that's the only thing that's said. Now again, we're gonna do say hi, and as you can say, it's saying hi there with the a question mark. But we can also say kedu, and it says kedu there. As you can see, you can say hola, and it says hola there. So what have we shown here? We've shown a command line interface where you're basically able to not just create this well-structured pattern, like it's got to say, and it's got to say hello, and that's the way it's got to be. But in this case, in the second case, we're also saying, hey, you can pass in hi, hola, okay, do as arguments, as potentially arguments into this, and it will also work. So if I did, of course, say blah, 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 obviously it's just going to fall down there. So let's change that actually right now while we have it. And let's just change it to say command not found, right? Okay. And so in here where you have your command not found, you can then basically potentially just loop through and essentially sort of like list, oh, here are all the things that that you can do, right? Here are all the flows that you can actually take on this application, so you can present them there, right? So that is that. The next thing that we can do is we can actually change it, add another one, right? I'm going to call this variables. Okay. So in the case of a variable, you literally don't know what it's going to say. So we've gone through, and in the first case, we showed a static value that you have to pass in. Then we showed optional values that can be passed in. And now in the final case, we can actually show passing in a complete variable. And the way we represent a variable is just to use a star. So if there's a star, what it tells the program is, hey, just ignore this particular token and just match it. Just call it a match, right? And you'll notice that nothing else needs to be changed. So I'm going to just call this random blah blah there, right? So nothing else needs to be changed. We still access the next variable in the same way, because all we're really doing is saying, hey, this is say, whatever's the next value, take that, and then process that. So let's run that. And say hi there, say blah, 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 random blah, blah, blah there, right? And there you have it. I'm going to make this a little bit nicer by using quotes in there, right? So that it just says some random value. So let's try that again. Always important to do these things as right as you can. So say blah, 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 right? Oh, didn't find it. Oh, say got some parameters in there, yes. So with the command line parser, one thing to note is that things like semicolons, stuff like that, are boundaries that are respected by the parser. So so your program should avoid any special characters like that where necessary, and you should not need to add add colons into the arguments that you're passing anyways. So we've gone through that and we showed variables. Now let's talk about something else that can happen with your program, which is that you have multiple arguments and you want them to be processed a certain way. So take a look at this right here. We have this say and we have an asterisk, right? But what if we were to change this, and what if we were to add multiple arguments, right? So let's add another argument in here, world. Okay, just like that. Okay, so okay, so here I'm really trying to show the reason for sequences here. Okay, so if you recall, as we stated in the first case, the order of these does not matter as you do them, right? So we can show this very quickly here. You can pass in world. I think we did this already, but let's try it again. There we go. So as we showed before, the reason why say needs to be first is because in the switch statement, we literally check for that first of all. So I couldn't do hello world say or anything like that, right? I'd have to do say hello world, right? Or I can do say world hello, right? Those both work. Now, you'll notice that for the extra arguments, they can be switched in any direction. So once we go down to this last one, right, I can go say blah, 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 world, right? Oh, so say, move here, world. There we go. So as you can see, it's going in here. Why is it going in here? Because there is a random character. In my definition, I'm saying that there's going to be 3 words. One of them has to be say, one of them has to be world, and one of them can be any word at all. And we already know from the way we've coded this that say has to be the first word. So basically between this and world, they can both be whatever they want to be, right? So what are the implications of this, right? Well, the big implication is that if I was really trying to get the value of whatever was passed in of the variable itself, it's possible that I might not get it right because I can do say and I can do world, and then I can type this stuff. And when I type this, my response is going to be random world there, right? If it actually works. So you would think that this would work, but it's not working. And why is it not working? And it's for good reason. It really has a lot to do with the way that the star variable or argument is handled. Now, if you look at the code here, you'll notice that I'm saying say, star, and world. And if I do it that way, like if I go say, right, and then world, then it works normally. But if I reverse it in this case, say, world, and then it's not working. So the reason that it doesn't work in that secondary flow, in that second approach, is that if you look at this, whenever we encounter the star, whenever the star is encountered, it immediately takes up the very next word or term that's passed in. So in this case, I passed in say, and then the very next word after say, because it's processing it sequentially, it's going through and trying to match whatever you pass, and it says, hey, does it have say there? Yes. And then the next thing it's going to do is, now that say is done, right next to say, does it have a variable Is there a word there, essentially? And whatever word that is, in this case, world, that's going to take up the star. So what it's expecting next in this sequence that I have here is world. So if I were to type say world, world, that's going to work. So the moral of the story is that even though everything switches when it's regular words, when it's a word like that, it's not going to switch, right? And this is illustrated actually by us using the same word multiple times, right? So, for example, say hello world, hello. So in this kind of scenario, right? As you can see, say hello, hello world works. Say world, hello, hello works. And say world, say hello world, hello. Those all work. Why do they work? Because each position, each time you find a match, it removes that position from the search order for next matches, right? So once I find a match on hello the first time, then that position is not going to be searched again. I'm going to basically skip it because it's been found and only be looking for world and hello. And once I find world, I'm only going to be looking for hello. And once I find hello, then I know that the entire flow has been matched. When you apply the same lens to this here, it first finds say, and then it tries to find hello. It starts from left to right, trying to find the star. Star is going to be any word that comes up. It doesn't matter. So the first item that's found after the previous item that was found, in this case, hello, will basically satisfy that. Then it moves on to the next one. So that's a little bit of a safeguard that allows for the most part, in these scenarios where you're using an asterisk, that allows for this kind of functionality to work there. Okay. But there's a much better safeguard. And the much better safeguard is using sequences, right? So when you use a sequence, you basically are tying a variable to show up in a specific sequence that you can then process later on. So how would this work here? So let's say you wanted this to basically be say hello world. Let's go up here and let's do that. So I wanted to actually say hello world. The easiest way to make it a sequence, I stop that, is to just add a comma, right? So if I switch it and make it like this, right, then when you're passing in your arguments now, this stops working, right? Because it's expecting hello and then world. And this is the notation for that. So if I do say hello world, that's going to work. Okay. And sequences obviously, because of the notation here, cannot be put into sequences, but sequences can also have random ordering, right? So over here, I can then say, let's say hello world. Okay. So in this case, I have two sequences that I can run. One of them is the hello world and one of them is name Edward. Okay. So because these are the arguments in there, I can do them in any order. So I can do name Edward, then say hello. Oh, I'm sorry. Name Edward and then hello world. So over here, you would type hello world, name Edward, hello world. And there you go, you have a hello world. And you can also do it in the reverse, say hello world, name Edward, and that will also work. But what you will not be able to do is hello Edward, name world. That won't work, right? Because these have been set up to be sequences that must go in a certain order, right? So what's the value of that? The major value that you get from doing that, I'm going to turn this back into how it was before, is that you can be assured on the location of your variables, right? So for example, if we're going to do something like taking parameters, right? So I can do, say, hello, comma, star, okay? And over here now, I'm taking a hello, and get rid of that. I'm taking a hello, and then the next value is a variable. And of course, the whole entire flow, everything we've worked on in the past should continue to work as it did, right? So we're accepting it as a variable. We've got say hello star. And if we were to run this right now, it would return hello, right? Because it's following the sequence. But actually what we want, now that we know that it's always going to be a star after hello, we can actually go in here and type hello. And then we can then basically get what it says. Right? So let's run this now. Right? So saying hello to James. So this is a great way to basically pick up capabilities and pull variables in, right? So let me do something a little bit more concrete. So over here, let's go with name, and then age, star, and then gender. And over here, I'm going to just use a binary notation here, not to offend anybody, but I just don't want to. I don't know what all the labels are, so I'm just gonna use M and F. Okay, right. So now what we have is a form sort of capability where the person can enter their name, their age, and their gender, and they have to enter it kind of in that order, right? And then here we should actually read some of these things. So name. So we'll go with name, age, gender. Okay. Actually, I'm going to change this to male and female just to make the sentence a little bit better. Okay, there we go. So let's run this now and see how it works, and then we'll talk a little bit about what we're actually doing. So say name Edward, age 68, gender male. And so we run that and it says, hello, Edward, you are 68 years old. You are a 68-year-old male, right? So what's going on here? We're basically reading this sequence. This is a sequence that has optional parameters of male and female in there. It also has the flow of name, star, age, star, and then gender. Star represents a value. You can pass whatever value you want to pass into it. Age can pass whatever value you want to pass into it. And then for gender, the choices are male or female in this particular program for the purposes of just illustrating it, not a representation of all the potential genders that there are. And the reason why there are not any more genders here is because I am not sure what all the genders are right now. And I don't want to go and be looking it up, and I don't want to type a whole bunch of things. So I'm just really keeping it as binary as possible just for the purpose of this, right? It is not in any way a representation of my views on all the various genders that are out there and all the communities that represent those genders and are associated with them. So just just putting that out there so you know that I am with you. Right. So that's basically it. Those are all the scenarios that the parser supports. And we've very quickly built a simple parser that I'm sure that you can imagine, simple command line parser that I'm sure, as you might imagine, you could do a lot of amazing things with. The value proposition here is that you can keep things relatively smooth. You don't need to be worrying about like minuses and all sorts of things like that. But if you wanted to, you could. So I could go in there and I could, change all these like that, right? And then that would create sort of like the same kind of program. Oh, I made a little mistake here. So let me just quickly fix it before we go on. Obviously, I'm using the minus to represent command line flags, right? And then the other thing that so running that real quick now that those have all been added. Let's see here. Here we go. So we can go in here and we can say name John, age 33, gender female, right? And that goes through the same. So that's more like a traditional command line interface, like what you might see in a traditional command line interface. But of course, in a traditional command line interface, you would not sequence all of these, right? So people will be able to write them however they see fit, however they choose. So you would have something more like this, right? So in this case, what I'm doing is it's a combination of multiple sequences. The name sequence, the age sequence, and the gender sequence is being used here. So I can swap them out in any order. I don't have to necessarily put name first, right? So running it like this, I can do say age 12, name Eduardo, and gender female. Oh, it's not gonna work, gender, which is good, right? Typo doesn't work, female still doesn't work. Name. Oh, well, gotta have that right there because this is a cool command line. And there we go. Hello, Eduardo. You are 12-year-old female, right? So that's it for now. But before we go, let's just add one more thing, right? So as you can see, we've done all this fancy stuff and we've created all this fancy stuff. Now, wouldn't it be nice if there was a way to basically simplify this and not have to write all this code, and maybe even as the process develops, provide a mechanism for when the command is not found, actually printing out all the potential commands for the user so that the user knows what they can do? I'm glad you asked, because there is such a thing. So what you can also do, instead of using parser, in here, create a command line interpreter. So let's just show how that would work. So the first thing we need to do is, let's start with, actually, we'll just put it in here. Let's start with our command line interpreter class. Okay. Stop that. And then we're going to define all the arguments that you can pass into the command line interpreter. Before doing that, let's just do a CLI.interpret, right? And then in here, we just pass the full command line, okay? And then for this CLI, right, we have not interpreted. And then when not interpreted is called, we're gonna go here and we are just going to print out the same console command line that we've already been using, right? Now, how do we handle when, when the matches occur, right? So on CLI, you actually have an indexer which represents all the matches that you need to, that you can match on. So the first one is say hello world. Okay, so you tap that in, then you go matched. And you must pass in the actual command line parse results, because that's what contains all the context that you can use to print things out as needed and read variables, right? So there's your hello world. And then the say hi okay is the next one. This is basically say hello hi kedu. Okay. And over here, this is a little bit more complicated. So we are actually going to have a multi-line statement for that one, because we're actually reading a value out and then using it. And as you can see, parse results is not there. So I'll change this to say results. Okay, result, not results. And the result is what we use to basically process now. Then the next one was this say star world. And I believe this didn't really do much. Oh, it did. Okay. So we take that and we put it here. And then the final step is this guy right here. for the final step, get rid of all that and put it here. So in essence, we've basically gotten rid of all of this code. So I can comment it out and replace it with all this. We don't have to worry about the switch statements anymore. And then let's run this and see what happens. So there we go. Let's start with that. And there you go. Basically works the same, simplifies the process, and essentially does the same thing. So as you can see, the application basically works the same way. The real advantage of using this way, besides the fact that the notation is a little bit smoother, easier to work with, is the fact that you can do you can basically display the command line and display all the options so that the user can see it without you having to go in and type all that stuff in. So what I've done is I've actually like updated to the latest version of the NuGet package. And with the latest version, you get that capability. So all I have to do here is type all options. Okay, so typing that basically will allow you to get those parameters, or will pass those parameters in. Of course, this does not do it automatically. So you do have to actually go in and display all options here. Right, so so let's go ahead and test that out. So we'll just enter bad arguments now. And as you can see, entering bad arguments, it actually displays all the options that you have available to you. You don't have to do anything to get that capability. The other thing you'll notice here is that there's a little gap there, and it's sort of like saying option dash, and there's a little gap there. So you can actually add some labels to each one of these options. Right now, I don't have them. Adding the labels is pretty straightforward. So over here, CLI match, you can do that label. Now, one thing to point out is that set label. There we go. One thing to point out here is that you don't need to, I have this set up in this manner, but you can actually just you can actually just create this matcher, which is what these are called, command matchers. Set the label, configure them how you want, and then just add them to the matching by passing them in as variables here to the indexer. But in this case, I'm just going to go in and I'm going to move this down one step so that it's easier to read. And I think that's it. And we won't be needing this anymore. So I'm going to get rid of all of this down here because that's basically redundant. Compress the code a bit. Okay. And so we can just go in and give some labels here. Simple hello world. Hello world with optional okay. I'm actually going to get rid of with with optional parameters. Over here, I'll say with variables. And over here, I'll say okay. And so that's how that would be configured in your program. And what you're looking at here is a full-on CLI that can be used to display my name, age, and gender. But if I mess up somewhere, will give me the options to say, okay, with optional parameters, with simple hello world, with variables and combination of all possibilities. The library tries to go from least arguments to largest arguments. As you can see here, it's reordered it because there's 3 parameters here, 3 parameters here, multiple parameters here, but only 2 parameters here. And of course, remember, it's driven by sequence. So a sequence is 1 parameter. So if you have a very large sequence with a lot of options that have to happen in a certain order, that will show up before all of these, right? But again, it's a work in progress, the library. But it's up and running. So links are in the description. In my next video, I'm going to be showing you how to do this with sequence diagrams, how to basically parse what's called a mermaid syntax for sequence diagrams, and how to use that to do super fancy, complex code generation, or really anything you want to do, pass some type of behavior from in what's called a DSL, or domain specific language, from one program to another. So once again, like and subscribe if you like this video. Support the channel, share it with other users, and let them know, we're coding here. Leave any comments below if you have any specific topics that you want me to talk about, any style of coding that you want me to address. We can really get into a whole bunch of different things and have some fun. So thank you very much. And as always, like, subscribe, share, and we'll see you in the next video.